Hi, in this question, we will compare the intensities of the planet and its moon. And this question is about the subunit B1. Okay, so in this question, they say that average temperature of the surface of the planet, not the core of the planet, surface of the planet is how many times? 5 times greater than the average temperature of the surface of moon. And why the temperature of the planet is 5 times the temperature of the moon? Because the as the size of the celestial body increases, its temperature also increases. This is the common observation that had been observed in all the celestial objects. Okay, now so its temperature is 5 times, so size of the planet is more than the size of the moon. Okay, now the emissivity of the planet and the moon are same. It means that eb is equals to em. All right, this emissivity. So average intensity radiated by a planet is I. Okay, so what is the intensity? First of all, I will explain you because our syllabus for IB has changed. So let me tell you, the intensity, dear students, is equals to energy radiated per unit time, which in other words you can say power divided by area. So intensity of the planet means that how much energy that planet is radiating in 1 second from 1 meter square. This is the intensity. And in our new syllabus, this you can consider the intensity to be the apparent brightness. And this is a power because that's energy over time. In our change curriculum, you can consider its luminosity divided by area. So its unit must be in watts. So anyways, the intensity radiated by planet is I. According to this question, what is the average intensity radiated by moon? Okay, how can we compare the intensities of these two objects? So let's understand what the Stephen Boltzmann law says. So it says that intensity of the black body is proportional to the fourth power of Kelvin temperature, absolute temperature. So when I will place a constant and this emissivity, this is a constant, Boltzmann constant, T raised power 4. So we are going to use this, in fact, this formula to compare. So for planet, that is I is equal to emissivity of the planet, sigma is the same constant, and the temperature of the planet raised to power 4. So the intensity of the moon should be equal to emissivity of the moon, and by the way, both are same, and T raised power 4. So it's better if we take their ratios, okay? Because we want to find out emissivity of the moon, so we will keep it in numerator divided by I is equals to em sigma Tm raised to power 4 divided by. So students, emissivities are same, which means that the ratio of the radiated intensity to the radiated intensity from the black body, that's emissivity actually, that how much percentage of light is radiated as comparable to the intensity radiated by black body, because black body radiates 100%. That's why in emissivity we always compare the intensity radiated with which intensity? By black body. Okay, uh, anyways, this will be cancelled out, and I am, can we bring them into the one bracket so it will be easier to solve? Okay, now you know that the temperature of the planet is 5 times, so if it is Tm, temperature of planet is 5 times the temperature of moon, so we can solve like this, and it will be cancelled out, and that is 1 over 5 raised to power 4, and that is equals to 1 over 625. So finally it means that, dear students, the intensity of the moon is 1 over 65 1 over 65 times of intensity radiated by the planet. So that's very small as comparable to that. So that's why the right answer should be option C.